Hello, Legacy students, Marsh here. So today we're going to talk about how to graph absolute value equations with tables, and we're finally expanding upon, beyond lines. Yay us! So, key idea today is the idea of value begins with V, okay? And you'll understand that in a little bit. What do you want to have on you? You want to have the foldable for today, pen or a pencil, and you may need a calculator just to do some simple adding and multiplying and stuff like that nature. Learning objective. I can graph an absolute value function using a table. Now, we want to talk about the absolute value function parent, which means what is the start of it. So, first thing, let's get a graph. Well, a normal absolute value function looks like this. Y equals absolute value of x, so the little two bars, right? And if you remember, absolute value means everything goes to positive. So if I have the absolute value of -1, that would be 1, right? Absolute value of 0, 0. Absolute value of 2, 2. Absolute value of 4, 4. Now, let's graph those ordered pairs. So I got -1, 1, 0, 0, 2, 2, and 4, 4. Now, what this graph's going to look like is a V for value. Okay, so V for value for our graph here. So we're going to be graphing this absolute value. Let's answer some of the questions here. So domain, how far left, how far right? Well, that would be -infinity to infinity, right? Goes forever to the left, forever to the right. Range, I only start at 0, and there's a bracket because I'm touching it, to infinity. This graph is continuous. And this one in particular, he would be even, because remember, even means I fold over the y-axis. So since I'm folding over the y-axis, this guy would be even. Maximum. Well, there's no hill, right? No hills on this graph. So I would say there's no maximums. The minimum, though, the absolute minimum, would be located at 0, 0, right? There would be no other minimums, so I'd just say he has an absolute minimum at 0, 0. Intervals of increasing. So remember, that's the car idea. Well, I am decreasing starting at -infinity, because remember, we're talking our x values for this, and I stop decreasing at 0. I'm going to start increasing at 0, and then going towards infinity for my increasing. Okay? End behavior is kind of new. This is new. It's asking what's going on the left and what's going on the right. So as x goes to -infinity, that's what this is, goes to, okay, -infinity. So as I go to the left, what does the graph do? So if I go to the left, the graph is going up, right? So f of x is going towards infinity. And then they're asking, as x goes to infinity. So this is keyword for what's happening on the right-hand side of our graph. On the right-hand side of my graph, so as x goes to infinity, f of x, the y, is going towards also infinity, right? Because they're both pointing upwards. X-intercept, so where we're crossing the x-axis, is 0, 0. Y-intercept, also 0, 0. So this is what's known as the parent function. Whoop, that's weird. Pen went a little wonky there. So this is a parent function of the absolute value graph. It is the default version before we've moved it, changed it, done anything to it, okay? So that was the parent graph. Now, being that we have a table and we have this thing, what I'm going to do first thing that we're going to do is we're going to set the inside equal to 0. That's going to give us the middle of my table. So I'm going to set x plus 3 equal to 0, and we're going to get x is -3, right? So that's my first x value. That's my middle point. Then what I'm going to do is fill some groupies around them, some numbers. I'm going to put -2, -1, -4, -5. Okay? Just put some numbers around that number. Now, what I need to do is plug those into my function to see what's the y value. So I'm going to take -1, plug it in. -1 plus 3, that's 2. Absolute value of 2, 2 minus 4, -2, right? Let's try -2. -2 plus 3, 1. Absolute value, 1. Minus 4, -3. -3 plus 3, 0. Absolute value of 0, 0. Minus 4, -4. Nearly there, right? -4 plus 3, that is -1. Absolute value of -1 is a +1. -4, -3. Now, these should always match. If they don't, you done did it wrong, okay? -5. -5 plus 3, that's -2. Absolute value of -2 is 2. -4, -2. Again, matchy-matchy. That should happen. If you don't, A, you found the middle weird, wrong, or you did some math wrong. Let's graph this V. -1, -2, -2, -3, -3, -4, -4, -3, -5, -2. Whee! Whee! My lines are almost on point today, or on fleek, one might say. So, vertex. Vertex is, where's that turnaround point, the middle guy? He's at -3, -4, right? Okay. Where is his intercept? Well, I crossed at, well, I got 3 of them, right? I got some x-intercepts. One of them looks like it's at 1, 0. And then I also have a y-intercept at 0, -1. And then where does this guy go? I kind of messed a little bit. -7, it looks like. Sometimes you might need to extendo those arms to make sure you can find those x and y intercepts. And if they don't cross perfectly, that's okay. Just kind of guesstimate. Is this graph continuous? Yes, definitely, right? Definitely continuous. I don't have to pick up my pencil when I'm drawing it. Boundedness. Can I draw a line on top? No, right? Because the arms are just going to punch right through it. So, can I draw a line on the bottom? Yeah, right? There's a point on this graph that the graph does not go below a point. So I would say he is bounded below. Okay? Even, odd, or neither. Looking at this graph, I can't fold it on the y-axis, right? So it's not even. Odd, remember, is fold over y, fold over x. That's definitely still not going to line up. Definitely a neither graph. Let's talk increasing, decreasing. Remember, that's if the little car. So I got my little car right here. He's driving down, so he's decreasing. Remember, it starts at the x values. So we're saying we're starting at -infinity. And he stops decreasing at right here at -3, right? Okay, and then I start the increasing at -3 towards forever in the x value, right? So I would be increasing -3 to infinity. And then, does this graph have a max or does it have a min? Well, in this case, he has a minimum, right? And his minimum is located at -3, -4, also known as the vertex. Okay. Let's talk domain. Domain. Well, we go forever in the left, forever in the right. And I'm going to tell you a secret, guys. That's going to be the domain for every single one of these absolute value graphs, okay? They always go forever in the left and the right. Range, well, he starts at -4, right? He goes forever up. So -4 bracket to infinity. All right, so let's talk through this next example here. So again, first step, we're going to set whatever's in the absolute value, and we're going to set it equal to 0. Solving, we're going to get x equals -1/2, right? So that's going to go in the middle of our x values. Now I got to put some groupies around him. Well, -1, right? Then I'm going to go to 0 because I don't want to count by halves, okay? Tell me, say terrible, but, you know. Oh, actually, that would be the wrong direction. Haha. Let's go -2 up there. Okay. 0 can go here, and then let's put a 1 there. So then I jumped by a half in between here, and then a whole 1. Let's plug them in. So -2 times 2 is -4, plus 1 is -3. Absolute value of -3 is 3. Tack that negative on. So now it's -3 plus 3, 0. I know, lots and lots of thinking, but we got this. -1 times 2 is -2. Plus 1, that's -1. Absolute value of that's 1. Tack the negative on, -1. Plus 3, that is 2. Let's do the 1/2. -1/2 times 2 is -1. Plus 1, 0. Absolute value of 0, 0. -0 is, well, still 0. Plus 3, 3. 0 times 2 is 0. Plus 1, 1. Absolute value, 1. -1, because that negative. Plus 3 is 2. Yay, they match. Let's try the 1. 2 times 1 is 2. Plus 1 is 3. Absolute value, 3. -3 plus 3. Whew, also 0. Whew, we got it. Okay, -2, 0. -1, 2. Half 3. 0, 2. Whoa, and 1, 0. My graph went a little wonky there. Let's clean that up so it's easier to see. There we go. 0, 2. Okay, let's graph that line. Kind of a skinny little guy, isn't he? Vertex. His vertex is, well, in the middle, so that's -1/2, 3. Intercepts. Well, he crosses at -2, 0. 0, 2. And 1, 0. It looks like. Is he continuous? Yup. Bounded. Well, I can't draw a line on the bottom like last time, right? But I can draw a line up top. So he is bounded above. Okay. This guy is also neither uneven, odd, or neither because I can't fold him perfectly over the y, and I definitely can't fold him twice to make him line up. He is increasing to start out with. He starts at -infinity. Stops increasing at right here, which is -1/2, right? Which means he's starting decreasing at -1/2. Whoopsies, I'm running out of room. To infinity. This guy in particular has a maximum, an absolute maximum to be exact, which is -1/2, 3. His domain, just like his friend, -infinity to infinity. And then remember the range, bottom to top. So he goes forever in the denominator, in the down, but he stops at bracket 3. Okay? So we're still practicing that key features of graphs that we started a couple of days ago. In summary, stuff you want to know. Absolute value graphs are going to be a V shape at all times. If they don't turn out to a V, you plug the wrong numbers in. Finding the vertex by finding the x value that makes the absolute value expression become 0. That's the key information today. Complete the table. Plot points. Is it a V shape? It should be. Giant V for value. Okay. And that's the end of this video. I will see you later, Sabers.